Okay, the second activity in Unit 4 is electric resistance. So we've talked about amps as being the current or flow through the wires, and volts as being the energy in those electrons that are flowing through the wires. So what is resistance? Resistance is how much a component in a circuit opposes the flow of electric charges. Think about walking down an empty hallway in the school, and then think about a hallway with a lot of students in it and your ability to get through it. That is resistance. Resistance is measured in ohms. That's the Greek letter omega, which is the symbol. The first thing that you have to understand is how the wire affects resistance. So when the electrical current is flowing through a wire, the length of the wire increases the resistance. The temperature of the wire also increases the resistance. Because the particles in the wire are bouncing around more, think about kids being in the hallway who are highly active and moving all around. It would be harder to get through them. Now, think about the thickness. Think about a hallway, and if we decreased the hallway, the thicker it gets, the less the resistance. So if we have a very wide hallway, if we've got 20 students standing in it, it would be easy to get through. But if we had a very thin hallway, all of those students would be compacted in. The material, it does depend on the type of material. So we don't just use copper for wires. So if we alter the material, we can alter the resistance. Now, another thing that's going to be important here is our load. Our load is where we are trying to use the electrical energy. So for example, in a motor, in a fan, in a light bulb, those are loads. What happens is resistance causes transformation. So what does that mean? If we have resistance in a circuit, once we hit a load, it transforms what that electrical energy is doing. So in a light bulb, what's happening is the electrical energy is being transformed into light energy. In old light bulbs, what happened is if we hit resistance, instead of going into light energy, which only 5% of the energy did, the other electrical energy went into heat. So sometimes when we transform electrical energy, we are trying to create heat, like in a dryer. Another thing that we can transform electrical energy into is movement. So in a fan, which is a load, we change the electrical energy into movement. Point 1, you have to know the things that affect resistance. Point 2, you're going to have to know how to read resistors. So when you go through the content, you'll see what a resistor actually looks like. So a resistor, these are wires coming out of the end of a resistor. A resistor is a small cylinder and it will be color coded. So just for my example, you read from left to right, and I've got red, violet, orange, and gold. You'll actually see the colors on a resistor when you go through the course content, but I had to put RVOG in there so you knew what the colors were on the resistor. If you look at a resistor in this course, you're going to have to know how to read it. From left to right, the first one is red. You go to this column. So for the first and second colors, you go to this column that says digits. There's red. Red is 2. So I'm going to write a 2 down. The second one is violet. So for the first and second colors, we go to this column here. Violet is 7. For the third color, orange, we go to the multiplier column. It'll say third in brackets. The multiplier is the third one. So let's go to our orange and see what its multiplier is. Its multiplier is 1,000. So we are now up to 27,000 ohms for our resistance. Our fourth one, gold, so there's gold in the fourth column. This is our tolerance, which means how accurate are we? It's plus or minus 5% of 27,000. So they will show you how to do the range when you go into looking at this chart. What I've showed you how to do is read the 4 colors that are in a resistor. We've got a 27,000 ohm resistor, plus or minus 5%. That is the second skill that you need in Activity 2 of Unit 4. Now, the third thing you must be able to do is manipulate the formula for Ohm's Law. So Ohm's Law states that the voltage across a resistor is directly proportional to the current flowing through the resistor. So in an Ohm's Law type question, you have a very straightforward formula: resistance equals voltage over amps. Now, we can rearrange that to say voltage equals amps times resistance, or amps equals voltage over resistance. Remember that we can take this formula and we can split it up. So if we know two of the three components of a circuit, we can get the other one. If we know the amps and volts, we can find the resistance. If we know the amps and resistance, we can find the volts. And if we know the volts and resistance, we can find the amps. I want to point out that if they have an ammeter, something that reads the amount of amps in a system, it's always in series. If we have a voltmeter, it's always in parallel around a load. So it's always hooked up to go around whatever that load is. In this case, our load is a resistor, but our load could be a light bulb. And we put wires going from the start to the finish. Now, if you want to play with a simulator, I'm not sure that the one that we have in the content is great. The one thing that you can do is do a Google search on Ohm's Law simulator, and one of the first ones that drops up or drops in will be PHET, P-H-E-T. If you click on that one in your search, you're going to find a good simulator there. The other thing you can do in the Google search bar is just put in phet.colorado.edu /en/simulation/ohms and then a -law. Either one of those will give you a good simulator to play with if you want to work with this simulation.